Hi guys, I'm Shrini and this is Lab 3, Black Hole. The goal of this lab is to analyze the motion and orbit of a star around a black hole and estimate the mass of that black hole. In the previous labs, we used known forces and physics principles to predict the motion of an object, but in this lab, we will work backwards and use the object's motion and physics principles to find the forces acting on the object and find its mass. We will do this by expanding on the GlowScript code given in the lab instructions and using our physics principles. There are two main physics principles we used in this lab. 1, Newton's second law, or the momentum principle. 2, Newton's law of universal gravitation. So Newton's second law is dp over dt equals F net, which is the rate of change in momentum. It can also be written as P initial equals P final plus F net times t, which is the duration of the motion. We were told in this lab that the net force of the star is solely based on the black hole, so our F net is Fg, or the gravitational force on the star. Newton's law of gravitation states there is a force of gravitation between all masses in the universe. The equation is written in the slide above, where g is the gravitational constant, which is about 6.674 times 10 to the negative 11. m1 and m2 are masses of the two objects, and r is the distance between them. Another important component in this lab is the parallel and perpendicular components. F net is equal to the sum of the parallel and perpendicular components, and this is the same for the rate of change in momentum. So the total rate of change is the sum rate of the change in the perpendicular and parallel components. So finding the F net and using the Newton's second law, we can find the components to add into Newton's law of gravitational formula, as I mentioned before, and solve for the mass of the black hole. So before we begin the lab, there are several things we need to assume. 1, assume the black hole is not moving because it has a larger mass. Assume the black hole is located at the origin, so the vector 0, 0, 0. Also that the mass of the star is 2.0 e to the 30th kilograms. The star's trajectory is defined by the unique email ID we had to put in, and that 1 day is equal to 86,400 seconds. And also that the black hole is the only thing acting on our star or object, so the net force is equal to our gravitational force. Okay, so for the GlowScript code, there were several things we had to add. First, our g value, our mass of the star, and then our time interval. Once these variables are in, we can then add our equations. So first, we find the initial velocity and the final velocity. Then we find the initial and final momentum by multiplying the star's mass by the initial and final velocity. We can then use this to find the rate and change in momentum by subtracting initial and final momentum and dividing it by our time. And according to Newton's second law, our F net is just our dp over dt. We then need to find our parallel and perpendicular components. We first find F hat, which is our unit vector. You get this by dividing initial momentum by our magnitude. To find the parallel component, we need to find the change in magnitude of the parallel components and divide that by delta t, and then multiply that by our F hat vector. This will represent the change in momentum, thus also representing our change in velocity. Since F net is equal to dp over dt, we set F net parallel equal to dp over dt parallel. We can also subtract our dp dt and our dp dt parallel to find the perpendicular component, since dp dt total is equal to the sum of dp dt parallel and perpendicular. We set F net perpendicular equal to dp dt perpendicular as they are equal. Now that we have all of our components calculated, we can solve for the mass of the black hole by using our gravitational equation. Now let's see what happens when we run our code. Orange vector is F net, magenta is F net perpendicular, and cyan is F net parallel. F net parallel affects the changes in magnitude, F net perpendicular affects the changes in direction or velocity. So our final calculated mass is 1.04859 e to the 34th. Our first lab question. So numerically, F net is equal to dp dt. F net parallel is equal to dp dt parallel. Similarly, F net perpendicular is equal to dp dt perpendicular. They are the same values, however, they are calculated differently. For F net, you have to use Newton's gravitational formula. For dp dt, you have to use the change in velocity. Though they are equal to the same numeric value, they represent different things. F net is the sum of all the forces acting on the object, and dp dt is the rate of change in momentum, or the speed and direction. So our second lab question. So the answer is no, the mass of the black hole cannot be calculated. If the motion and the location of a star is unchanged, there's no different gravitational force to calculate the new mass of the black hole. This is because our mass was found using all these measures that we plugged in. If these measures are the same, then our mass will also be the same. Thank you.